Hello friends and students. So we'll continue solving problems using Mason's gain formula. Now in the previous two videos we have solved a few problems and we shall solve two more problems in this video. Now given an electric circuit, we need to draw the signal flow graph and also find the transfer function of the output versus the input, right? So this is the electric circuit given here. So what we'll first do is we have to write the Laplace transform network with all the initial conditions made equal to 0. So therefore the Laplace transform of the network is, so I have the input Vi of S. So you have resistance R1. The current becomes I1 of S. The capacitor becomes 1 by C1S. I have R2 here. And then here I would have 1 by C2S, and then the output voltage V0 is V0 of S. So this is V0 of S, and then I have I2 of S, which is the current in the second loop, and the voltage here is VA of S. So now let me first write the currents and the voltage. So the first one, what is I1 of S? I1 of S is nothing but the current flowing through the resistance R1. It is nothing but Vi of S minus Va of S by R1. So it is Vi of S minus Va of S by R1. So I can write it as Vi of S by R1 divided by Va of S by R1. Next, B. Let me write what is Va of S. Now Va of S is the voltage drop between this and this point, between these 2 points. So it is nothing but the current flowing through the capacitor C1. So what is the current flowing here? It is I1 of S minus I2 of S, because these two currents are in opposition. So I1 of S is flowing down, whereas I2 of S is flowing up. So therefore I have V of S is nothing but 1 by C1S into I1S minus I2 of S. Next, C, what is I2 of S? Now I2 of S is nothing but the current flowing through R2, right? So I2 of S is nothing but VA of S. So this is the voltage here, V of S minus V0 of S divided by the resistance R2. Very simple. Next, D, what is V0 of S? That is the output voltage. V0 of S is nothing but the current flowing through the capacitor. So it is 1 by C2S into I2 of S, right? So with these things, let us try to draw the signal flow graph. So how do we draw the signal flow graph? So I have Vi of S. In the next point being I1. Next I have Va of S, next I2, and next finally I would have V0 of S. So what is I1 of S? It is nothing but Vi of S by R1. So I can write it as 1 by R1 minus V of S by R1. So I have a loop here, minus 1 by R1. So you observe I1 of S is Vi into 1 by R1 minus Va into 1 by R1. Now what is V of S? Va of S is nothing but I of S by 1 by C1S. So I have 1 by C1S here minus I2 by C1S. So I2 minus 1 by C1S, right? Next, what is I2? I2 is nothing but Va by R2. So I have 1 by R2. And then V0 by R2 with a negative sign. So V0 of S multiplied by 1 by R2. And what is V0? V0 is I2 of S by 1 by C2S. So it is 1 by C2S. So we have drawn the signal flow graph here, right? So using these expressions, we'll be able to write the signal flow graph. And now what is the first step? The first step is to find the path P1. The path which connects the input to the output. So there is only one path which connects the input to the output. It is nothing but this path. So it is 1 by R1 into 1 by C1 into 1 by R2 into 1 by C2s. So I multiply all of them directly and I could write the expression as 1 by R1 R2 C1s C2s. Alright. Next, step 2. How many individual loops are there? There are 3 individual loops. So 3 individual loops. So what are the 3 individual loops? These are the 3 individual loops. So this is one loop, this is the other loop, and this is the third loop. So let me call that as L1, L2 and L3. So let L1 be equal to, so I have minus 1 by R1 C1s. L2 is minus 1 by R2 C1s. And then I have L3 is 1 by R2 C2s with a negative sign. Now step 3, you need to find how many combinations of 2 non-touching loops are there. So this is L1 and this is L2 and L3. So L1, L2 will definitely touch here and L2 and L3, but L1 and L3 represent 2 non-touching loops. So it is L1 and L3. So there is one combination of 2 non-touching loops, and it is L1, L3. So which is nothing but R1, R2, C1s, C2s. Alright. So now what is delta? Delta is 1 minus L1 plus L2 plus L3 plus L1, L3. Alright. And what is delta 1? Delta 1 is 1 minus. So you find that all the individual loops will definitely touch the nodes of the forward path. So it's going to be 1 minus 0. Very simple. So what is V naught of S by Vi of S? So it is nothing but P1 delta 1 by delta. So very simple problem. So what is P1? P1 is 1 divided by R1, R2, C1s, C2s divided by, what is delta? This is delta here. So I have 1 plus L1, L2, L3. So I've actually taken, if I remove the brackets, I get plus sign everywhere because all these 3 are negative, right? So I would get 1 plus 1 by R1 C1s plus 1 by R2 C1s plus 1 by R2 C2s plus L1 L3. That is 1 by R1 R2 C1s C2s. Alright. So now I can take the LCM. So if I take the LCM, what happens? I would finally get the expression V naught of S divided by Vi of S. So if I take the LCM here I would get R1, R2, C1s, C2s, and even here. So those 2 will get cancelled. So I have 1 by, I have 1 here. So I write the LCM R1, R2, C1, C2s square plus. So what is left over of R1, C1s? So I have R2, C2s plus. So here you have R1, C2s plus here I would get R1, C1, and finally you get plus 1, right? So this is the final transfer function V naught of S by Vi of S. So very simple problem. So let's take another problem before we wind up this section. So I have a set of differential equations and they are represented by these 3. Okay, so I need to find X of S by U of S. So the above set of differential equations are converted into algebraic equations by taking the Laplace transform. So for this, the first one, I have X of S equals X1 of S plus B3 U of S. That's the first one. The second one, I have X1 dot. So it is nothing but S into X1S equals minus A1 X1S plus X2S plus B2 U of S. Alright, or if I take S to the RHS, I have all these 3 expressions which get divided by S. So I'll write it as by S here. Alright, and then 3, I have S X2S equals minus A2 X1S plus B1 U of S. So again I bring S to the RHS. So both these terms get divided by S. So now using these three expressions, let me draw the signal flow graph. So I first write the nodes U of S, and then I have x2 of S, and then let me write x1 of S, and then x of S. So what is x of S? It is 1 into x1 of S, so I write 1 here, plus beta 3u of S. So from here you have beta 3. Next, what is x1 of S? It is minus a1 by S into x1 of S. So from here itself I have a loop, minus a1 by S, and then x2 by S. So I have 1 by S from x2, and then from u of S I have beta 2 by S. So this is going to be beta 2 by S. And what is x2? x2 of S is minus a1. So x2 of S is minus a2 by S into x1. So from here I have minus a2 by S, and then from u of S I have b1 by S, or beta 1 by S. So this forms the signal flow graph. So now I need to write all the forward paths. That is the path which connects the input to the output. So that is step 1. So how many forward paths I have? So let me consider P1. So P1 definitely is this path where I have beta 1 by S into 1 by S. So I have beta 1 by S square. Next, do I have another path P2? Definitely I have another path P2, which is this path starting from the input node, beta 2 by S into 1. So this path, beta 2 by S into 1. And then I have another path P3, which is from u of S to x of S straight, which is beta 3. So you have 3 forward paths here. Next, step 2. How many individual loops do I have? So I have one loop. So this is one loop here, minus a1 by S. And definitely you have one more loop here, which is minus a2 by S into 1 by S. Alright, so let this be the first loop L1, which is minus a2 by S square, and then the second loop is minus a1 by S. Alright, so what is step 3? Are there any non-touching loops? So these are the two loops here. This is L1 and this is L2, and you find that they share a common node. So step 3, there are no two non-touching loops. So no two non-touching loops. All right, okay. So therefore I have delta equals 1 minus L1 plus L2. And what is delta 1? So delta 1 definitely is this forward path, and you find that both the loops definitely touch the nodes of the forward path. So delta 1 is 1. What about delta 2? So this is the second forward path, which is beta 2 into S, and you find that both of them definitely touch this node here. So that is also 1 minus 0, so I get 1. And what about delta 3? So what is delta 3? So delta 3 is 1 minus, so I find that this is the forward path, which is beta 3, and both the loops do not touch the forward path. So it's going to be 1 minus of L1 plus L2. And what is L1 plus L2? It is nothing but delta. So delta 3 is nothing but equal to delta here. Okay, so therefore you have x of S by u of S equals P1 delta 1 plus P2 delta 2 plus P3 delta 3 divided by delta. All right, so P1 is beta 1 by S square into 1, delta 1 is 1. Next I have P2, which is beta 2 by S into delta 2, which is again equal to 1, plus beta 3 into 1. So I have L1 and L2. So both of them are negative. So if I remove the brackets, they become positive. So 1 plus A2 by, so A2 by S square, which is L1, plus A1 by S. So I have plus A1 by S. And then I have delta, which is 1 plus A2 by S square plus a1 by s. So this is the final transfer function x of s by u of s, right? So L1 is minus a2 by s square and L2 is minus a1 by s. So with this problem we shall conclude this topic, and in the next video segment we shall begin with the next topic in control systems. So do not forget to view all the other videos in control systems by clicking on the I icon or going through the playlist control systems, and make sure that you solve more problems in both Mason's gain formula to find the transfer function and also in the previous section. So I'll be back with the next video very soon in the next topic. Do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.